Most of the reactions that we will talk about in this class will occur in aqueous solution with water as a solvent. Therefore, it's important for us to understand what these solutions look like. How does a compound behave when it is in an aqueous solution? Let's start by taking a look at ionic compounds. The first thing to remember is that an ionic compound exists as a lattice of alternating negative and positive ions. So the negative ions are green here, the positive ions are purple. And when I put that crystal, that solid ionic compound into water, and the water molecules are depicted as red and white molecules here, with red being oxygen and white being hydrogen. When I put that into water, what happens is that the water molecules will surround the separate ions of sodium and chlorine, and eventually what you will see is that the sodium and the chloride ions begin to be surrounded by the water and removed into solution. So it's like the water comes and grabs the ions and pulls them apart and leaves them in solution surrounded by water molecules. The important thing to see here is that a solid ionic compound, when put into water, will break apart into its constituent ions. So a solution of an ionic compound consists of cations surrounded by water molecules and anions surrounded by water molecules. We can represent that in our usual fashion by noting that sodium chloride aqueous is equivalent to sodium plus aqueous plus Cl minus aqueous. In contrast, a covalent compound such as sugar, it's a glucose molecule depicted here, when it is introduced into water, will also be surrounded by the water molecules, but the covalent bonds that hold the atoms together in the glucose molecule do not break apart, and the glucose stays as an entity, as a molecule, an intact molecule in aqueous solution. So when covalent compounds are dissolved into water, they don't break up, but when ionic compounds are dissolved into water, they break into their constituent ions. This means that when we have an ionic compound that is made up of a metal cation and a polyatomic anion, the polyatomic anion is a covalent anion, covalently bound nitrogens and oxygens. And so when that ionic compound is put into water, what we end up with is sodium ions surrounded by water molecules and nitrate ions surrounded by water molecules. Notice that the covalent nitrate remains intact and does not break apart into nitrogens and oxygens. So when you have a polyatomic anion in your ionic solid and you put that into water, it will break apart into its constituent ions, but the polyatomic anion does not break apart. Note that when we write an ionic compound that is a 2-to-1 ratio, like calcium chloride, and we put that into water, the constituent ions in this ionic compound are calcium and chloride, and there are 2 chlorides for every calcium. So, but when we write this, we do not mean calcium 2+ bonded ionically to a Cl2 covalent compound. Cl2 is a neutral compound as a covalent compound, so it cannot form an ionic lattice with calcium 2+. Therefore, when we break this apart into its constituent ions, we get calcium 2+ and chlorides, but we get 2 chlorides because every 1 calcium comes with 2 chloride ions.